Problem 13. The period of simple pendulum is found to increase by 50% when the length of the pendulum is increased by 0.6 meters. Calculate the length and initial period of oscillation at a place given at a place where G is equal to 9.8 sorry 9.8 meters per second square. Okay, so that is, so here when length is increased by 0.6 meters, its time period is increased by 50%. Then what is the initial length and what is the initial time period of the pendulum? Okay, according to the question, so they are given that time period of a simple pendulum is found to be increased by 50%. Okay, initially something is there, but that is increased by 50% when length is increased by 0.6 meters. Okay, so first of all, we have to take the time period. So what is the time period? T is equal to 2 pi under the root of L by G. This is the initial time period T and initial length L. But this time period is increased by 50% when length is increased by 0.6. Means here I am writing like this, that is 2 pi under the root of this length is increased by 0.6, means L plus 0.6. Okay, when length is increased by 0.6, its time period is also increased by 50%. 50% of initial time period. Okay, whatever the initial time period, in that it is increased by 50%. Okay, so then G is same, that is equal to G. Okay, so then this is, we can write here T plus, this is 50% means 50 by 100 into T. Okay, so that is equal to, it is 2 pi under the root of L plus 0.6 by G. Okay, so this is 0.6. Then here we can take like this. Okay, so by doing the LCM, this is equal to how much? 100 into T, that is equal to 100 T, and this is 50 T, that is equal to 150 T by this is 100. Okay, so which is equal to 2 pi under the root of L plus 0.6 by G. Okay, so this is also we can write like this. Okay, so this is 1010 cancel, 5 2s are and 5 3s are. Okay, that is 3 by 2 into T is equal to 2 pi under the root of L plus 0.6 by G. Okay, so after cutting this, we got this is 3 by 2 into T. Okay, so but already this is equal to 3 by 2 into T. T is equal to, already we know that is 2 pi. This is 2 pi under the root of L by G, and which is equal to this one, that is equal to 2 pi under the root of L plus 0.6 by G. Okay, so 1 2 pi is cancelled, and this is equal to 3 by 2 into this is L under the root of L by G is equal to, it is equal to L plus 0.6 by G. Okay, so both side we have a root G, and this root G is cancelled, and it is equal to 3 by 2 into root L is equal to, this is under the root of L plus 0.6. if we are squaring on both sides, okay, so that is equal to, it is 9 by 4 into this is L, and it is equal to this is L plus 0.6. Okay, so then this is 9 by L, means this is 9L is equal to, by doing cross multiplication, this is 4 into L and plus 0.6 into 4. Okay, so that is equal to 9L is equal to 4L plus this is 0.6 into 4, means that is equal to 2.4. so this is 2.4. okay, so from that this 4L I'm taking this side, that is 9L minus 4L is equal to 2.4. from that 9 minus 4, that is equal to 5L, and that is equal to 2.4. from that L is equal to 2.4 by 5. okay, then L is equal to 2.4 by 5, it is equal to 0.48 meters. okay, this is 0.48 meters. then this is the initial length of the pendulum is L, and that is equal to 0.48 meters. then what about the time period when initial length is initial time period means, now we got the initial length, then that is substitute here, then we got the initial time period. okay, that is initial time period, that is equal to 2 pi under the root of L by G, and that is equal to 2 pi under the root of L is equal to 0.48 by G. G is equal to, so mentioned here, that is 9.8. and after solving this totally, we got it, that is, this is 2 pi means 2 into 3.14 into, that is, that value is 0.2213 for this root, and this is equal to, after solving totally, 1.389 seconds. This is our initial time period, and this is initial length.